All right, today's lesson is a continuation of yesterday's in this whole idea of classifying quadrilaterals. Now, we talked about the definitions, and the definitions are very limited of these quadrilaterals. And you might have been thinking, but I know that the opposite sides of a rectangle are equal, or I know other things about quadrilaterals that aren't in their definitions. And the reason that is because they're actually under the properties of parallelograms, properties of rectangles, properties of the different figures. The key here, as I always emphasize, is based on what I know and what I get. You have to know you have a parallelogram for sure before you get these qualities. So just as a reminder, the definition of a parallelogram is two pair parallel sides. Now, if I know that, so the first, we have 5 properties of a parallelogram. First one is that the opposite sides are equal. And we saw that in the homework assignment. That has to do, we can figure that out by using those parallel lines and those same side supplementary. We know that the opposite angles are equal. We know that the diagonals bisect each other. And I will draw a picture of that in a minute. I know that the consecutive angles are supplementary, and that has to do with those parallel lines. We played with that in the homework. And I know that the diagonals form 2 congruent triangles. Now, what does this mean when I look at a picture of a parallelogram? The only ones that are kind of confusing are the fact that the diagonals form congruent triangles. So if I draw that diagonal, this triangle and that triangle are congruent. If I draw the other diagonal, this triangle and this triangle are congruent. Now, the fact that the diagonals bisect each other is very, very powerful, but can be abused. It tells me that that and that piece are equal, and this piece and this piece are equal. I know nothing about the diagonals in relation to each other. I just know that it creates 2 equal parts out of each diagonal. Now, a rectangle, if I know I have a rectangle, I get additional properties. Now, what was the definition of a rectangle? The definition is a parallelogram, so I get those 2 pair parallel sides plus 4 right angles. So when I look at this little star, the little star tells me I get all of the properties of parallelograms, plus I get that the diagonals are congruent. So in a rectangle, I get that those diagonal pieces are the same. So if I, in a proof situation, would tell you that you have a parallelogram, you get 6 pieces of information. You get that the sides are parallel. You can say things about equal sides, equal angles, equal pieces of the diagonals, supplementary angles, and congruent triangles. If I tell you in a proof, as you're given, you have a rectangle, you get all 6 of those criteria plus 4 right angles plus equal diagonals. So it's going to become very important to start working your proofs backwards to kind of know where you need to go, because we have so much more information to choose from. If I know I have a rhombus, the criteria that I get, cute little star, I get all the properties of a parallelogram, because remember, a rhombus is a parallelogram, and I get that the diagonals are perpendicular to each other, and I get that the diagonals bisect their angles. Now, what does that look like in a picture? Well, if I grab, oops, wrong picture. If I grab a rhombus, what it means is these diagonals right here are perpendicular. Since this is a parallelogram, each of these opposite angles are equal, but these diagonals are going to bisect them. So those bisected pieces are also going to be equal. And now a square just has three little stars because a square has all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. Now, just to kind of put this all together and review a little bit, I'm going to skip the proofs for right now, and I'm going to look at the table that's in your notes. And we're going to work these criteria down, and I'm going to draw some pictures for you because some of the material is coming in a later lesson. But if I look at which figures have opposite sides parallel, the ones that have opposite sides parallel are my parallelograms. And that would include my rectangle, my rhombus, and my square. Now, I usually make a note that a trapezoid has one pair parallel, and an isosceles trapezoid has one pair parallel, just to help collect my thoughts. When I look at which figures have opposite sides equal, again, it's my parallelograms, which includes all of these guys, and not my trapezoid, but my isosceles trapezoid, the legs are equal. And if you remember, the legs are the non-equal sides. Kites don't have opposite sides being equal. When we talk about opposite angles being equal, again, all of my parallelograms have opposite angles equal. None of my trapezoids have opposite angles equal. And my kite has one pair equal. And to just draw you a quick picture of a kite, the pair that's equal is the pair between the non-equal sides. That is the set of angles that are equal in a kite. We'll talk more about kites in another day or so. Forming two congruent triangles, that was one of our parallelogram properties, so that applies to rectangles, rhombus, and squares. Does not apply to a trapezoid, and it does not apply to isosceles trapezoid, but it does apply to one of the diagonals of a kite. And again, if I draw my kite with my consecutive sides being equal, the diagonal that goes from equal vertice to equal vertice is the one that makes, the line of symmetry is the one that makes two congruent triangles. The diagonals bisecting each other was a parallelogram property. That belongs with all of those. And nobody else has that property. That is unique to parallelograms. Diagonals are perpendicular. That was a rhombus quality and a square quality. And what we're going to find out is it's also a kite quality. When the diagonals of a kite intersect, they are also perpendicular. The diagonals being equal is restricted to the rhombus and the square and the isosceles trapezoid. And if I draw you an isosceles trapezoid, it should feel pretty good in your gut that from this corner to that corner and this corner to this corner is equal. And in fact, those are our overlapping congruent triangles that we dealt with in Unit 3. And so I could go through the effort to prove to you by CP/CTC that those diagonals are congruent. But I'm guessing you believe me. Bisecting the angles. The only two that bisect angles are, oops, I got off one. Angles are perpendicular there. Diagonals are equal. I'm sorry, I got off on my notes. Diagonals are equal is a rectangle and a square and the isosceles trapezoid, which I just drew for you. Diagonals bisecting the angles happens in a rhombus and a square, and it happens with one of the diagonals of a kite. And that happens with that same line of symmetry diagonal right there. We'll bisect its angles. The last two are the easiest. All are right angles. Those are our rectangles and our squares. All sides equal is our square and our rhombus. This sheet forms a really nice summary of the entire unit. So tune in to part 2 of this video.